హలో స్టూడెంట్స్, వెల్కమ్ టు టాక్ ఆన్ సివిల్ ఇంజనీరింగ్. సో ఈ రోజు వీడియో లెక్చర్ లో ఒక ఎగ్జాంపుల్ ప్రాబ్లమ్ చూద్దాం ఆన్ రిజిడ్ పేమెంట్స్ ఫర్ స్ట్రెస్ క్యాలిక్యులేషన్ డ్యూ టు టెంపరేచర్ వేరియేషన్స్. సో ప్రీవియస్ వీడియో లెక్చర్ లో మనం స్ట్రెసెస్ డ్యూ టు వీల్ లోడ్స్ క్యాలిక్యులేట్ చేస్తాం ఇన్ రిజిడ్ పేమెంట్. ఇన్ టుడే వీడియో లెక్చర్ లెట్ us try to calculate stresses due to temperature variation or the warping stresses. For calculating warping stresses also we are going to use the equations provided by Westergaard. వీల్ లోడ్ స్ట్రెసెస్ డ్యూ టు వీల్ లోడ్ చూసినట్టుగానే ఇక్కడ కూడా స్ట్రెసెస్ డ్యూ టు టెంపరేచర్ వేరియేషన్ లో కూడా 3 పొజిషన్ లో స్ట్రెసెస్ ఈక్వేషన్స్ ఉంటాయి. ఆ 3 స్ట్రెసెస్ ఈక్వేషన్స్ ఏంటో ఇక్కడ నేను రాస్తాను. వీ హ్యావ్ టు రిమెంబర్ దిస్ 3 ఈక్వేషన్స్. సో వీఆర్ గోయింగ్ టు యూస్ these 3 equations for calculating stress due to temperature variation or warping stresses. Okay, now firstly let us write the given data from the given question. So here he is asking to determine the warping stresses at interior, edge and corner positions of 20 mm thick CC pavement. So the thickness of CC pavement will be representing in small h, 20 centimeters, and pavement with a transfer joints 12 meters. So let us consider this is our pavement with longitudinal joints and transfer joints. Okay, so this is called the longitudinal joints. So these are called longitudinal joints, and these are called lateral or transverse joints. These are called transverse joints. Okay, so in the question is saying that the transverse joints are having an interval of 12 meters. That means this interval of these transverse joints is 12 meters. Okay, and the interval of longitudinal joint is 3.5 meters. So this is 3.5 meters. Okay, so that means Lx is equal to 12 meters, Ly is equal to 3.5 meters. Okay, so this is Ly and this is Lx. He has given modulus of subgrade reaction as 12. Will represent with K. K is equal to 12 kg per centimeter cube. And the maximum temperature difference at top and bottom portion of the slab during the summer day is found to be 16 degrees. So the T is equal to 16 degrees Celsius. And the radius of loaded area, that is small a, the radius of loaded area is 15 centimeters. And coefficient of thermal expansion has given the alpha value, that is coefficient of thermal expansion is equal to 10 into 10 to the power of -6 per degree Celsius. So this is per degree Celsius. And the modulus of elasticity of concrete, that is capital E, is equal to 2.5 into 10 to the power of 5 kg per centimeter square. So this is centimeter square, sorry. And Poisson's ratio new value is 0.15. So Poisson's ratio is 0.15 for that concrete. Okay, so let us calculate the stresses. So before that, firstly we need to calculate L value, that is the radius of relative stiffness. So radius of relative stiffness is given by equation EH cube divided by 12 into K 1 minus mu square whole to the power of 1 by 4. So just substitute the values. Here E is 2.5 into 10 to the power of 5. H is 20 cube divided by 12. K is 12 itself. 1 minus mu is 0.15 square whole to the power of 1 by 4. So if we calculate this, we'll get a value around 61.39. So let us take it as 61.4 centimeters. Okay, so in this equation we need to substitute the values in centimeters and kgs itself. Okay, so we got L value. So L value we can substitute here. And what else we required? We required Cx and Cy. We required Cx and Cy. So let us calculate Cx and Cy. So to calculate Cx and Cy, we need a nomogram provided by Westergaard. Cx and Cy we got from a nomograph. And this nomograph is based on Lx by L ratios and Ly by L ratio. Okay, so but firstly we need to calculate Lx and L ratio. So Lx by L is equal to, what is Lx? We got Lx as 12 meters, 12, and L is 61.4. Okay, so but this is in meters and this is in centimeters, so I need to multiply 100 here so that it will come to centimeters. So this value will be around 19.5 54, and Ly by L. So Ly value is 3.5 meters into 100 divided by 61.4. So this value will be around 5.7. Okay. So now we have to refer the warping stress coefficient graph. Yeah. So here you have warping stress coefficient graph. We need to refer this graph to find out Cx and Cy. So here, so we got Lx by L ratio has 19.5. So, but here we have only 14. So greater than 14 or greater than 14, we can take the same value, that is the 1. Okay. So we can take all the values greater than 14. We can take the line intersecting here itself. Okay. So we have 19.5. So we can take Cx is equal to 1. Okay. And Ly by L is 5.7. So 5.7 means this is 4 and this will be 5. Maybe this will be 5.5 and here this will be 5.7. So that means somewhere here. Okay. So this is 0.8. So 0.8, just above 0.8. So maybe we can take 0.82 because half of this will be 0.9. Okay. So we can take 0.82 or 0.83 like that. So let us take 0.82. Now we got Cx and Cy values. We got Cx and Cy values from this graph. Now just we have to substitute. That's it. We got all the values required to be substituted in these equations. Just substitute in this equation and find the values. Now let us calculate the warping stresses. So firstly, let us calculate the warping stress at interior portion. Sigma Ti is equal to, what is the formula? E alpha T by 2. E alpha T by 2 will be common in all the equations, into Cx plus nu into Cy divided by 1 minus nu square. Right? Just substitute the given data. E is 2.5 into 10 to the power of 5 and alpha is 10 into 10 to the power of minus 6. T is 16 divided by 2. What is Cx? Cx is 1 and Cy is new value is 0.15 into Cy is 0.82 divided by 1 minus 0.15 square. Okay. Just if we put this in calculator, we'll get a value equal to 22.98 kg per centimeter square. Okay. So this is the warping stress or stress due to temperature variation at interior portion of the rigid pavement slab. Okay. Now let us calculate the stress variation, the warping stress at edge portion. Sigma Te is equal to Cx E alpha T by 2 or Cy E alpha T by 2. Okay. So Cx value is 1 into E value is 2.5 into 10 to the power of 5. Alpha is 10 into 10 to the power of minus 6. T value is 16 divided by 2. So this value will be around 20 kg per centimeter square. Okay. And for this equation, Cy is 0.82. E is 2.5 into 10 to the power of 5 and alpha is 10 into 10 to the power of minus 6. T value temperature 16 divided by 2. So this value will be 16.4 kg per centimeter square. So the maximum values, so this is the maximum. This will be our stress at edge portion. So sigma Te is equal to 20 kg per centimeter square. Okay. Now let us calculate the warping stress at corner portion also. So this is at interior. So this is at edge. And this will be at corner. Okay. So sigma Tc is equal to E alpha T by 3 1 minus nu under root A by L. So E is 2.5 into 10 to the power of 5 and alpha is 10 into 10 to the power of minus 6. T is 16. 3, 1 minus new value 0.15 into A. What is A value? A is the radius of contact area or the loaded area, that is 15 centimeters. So A is 15 centimeters and L is 61.4, right? So just simply put this in calculator. You will get a value around 7.75 kg per centimeter square. Okay. So this is the stress at corner, right? So this is how we are going to calculate the stress at interior portion, edge and corner due to temperature variation. Thank you all.